Okay, hello, students. This is Unit 6, lesson number 6 again, and Pythagorean Identity Part 2. So, this lesson is all yet again you're using Pythagorean Identity. I can use Pythagorean Identity to find the values of cosine, sine, and tangent of an angle if you know one of them and a quadrant, which quadrant the angle lies. So, go straight away to the problem. The first task is asked, look at this, is for any angle theta in the quadrant indicated, use mental estimation to identify the values of this positive. So you will just have to know whether it is positive or negative. All you need to know is in the first quadrant, remember, uh, in the first quadrant, both signs x and y. Remember, x and y both are positive. In the second quadrant, it is minus and plus. So x is negative and y is positive. In the third quadrant, both are negative, that is x is negative and y is also negative, and here positive and negative. So this is all everything that you know. Then all you're supposed to remember is the unit circle. Suppose this is the unit circle, any point, and you can draw triangle. Let's see if I can draw right triangle. So if I try to draw a right triangle, so this is the radius, and then see, and you draw a right triangle, and then you can clearly see that this is the angle theta, we say. Okay, when this is theta, this is the adjacent, and that's the opposite. And that's the hypotenuse, which is 1. So last time I showed you that if I want to write sine of theta, just a quick remembrance, sine theta is opposite over hypotenuse, and here the opposite is the this one. This is the y. So this is the y. So it's y. Divide by 1, which is y. That means your y is sine theta, the second one. And the cosine, if I want to write what is cosine theta, it is adjacent over hypotenuse. So adjacent is the this one, which is x. So that's x. So it is x divided by the radius is 1 here. So I put 1. So that means x is cosine theta. That means this x is cosine theta. So all you remember is, in short, all you remember is if we have a unit circle, this is the unit circle, okay, and then you say any point. So this is the starting angle, the beginning angle, and the other angle I always showed yesterday also. That angle rotates. So this can be here, it can be also here. So you can have this angle here, or you can have another one this way. You can have another one here. You can have another one here. See, so different angles. I'll take one at a time. And the first, if the angle is in the first quadrant, and you can see that it's in the first quadrant, this is theta, that's theta. Both are x and y, both are positive. So that means this in the first quadrant, both sine theta is positive, cosine also is positive. That means this is x, which is positive. I'll put plus. And cosine means y, that also is plus. And what is tan means? Tan is sine theta over cosine theta. How did we get this? Is because remember, if I drop this one, this is x and that is y. So if this is the theta, tan means SOHCAHTOA, tan is opposite over adjacent. So that means opposite is the y. This is the y that you see here, y, and divide by x. But y is so y is, can see y is cosine. I made a slight mistake here. This sine theta is y, and cosine theta is x. So please take note of that. Earlier I showed that. Be careful. So again I repeat. Let me clean this up so that it doesn't be. So let me do it one more time. That means cosine theta is x and sine theta is y. So therefore here you'll see this y over x, you'll see sine theta. So I'm going to write this here is sine theta over cosine. That means if these two are positive, cosine becomes positive. This is positive, this is positive. And even tan theta is also going to be positive. So that's the takes care of that. Second quadrant, if the angle is, let me take this off. Okay. So this angle, if it is this way, now the angle is, let's take this. Okay, so this one is here. So if the angle here, this is the angle which is theta, that's the terminal side. The red one is here. So the answer here is this. We know it is going to be minus and plus. That means your x is negative and y is positive. So naturally, the definition says, see, this definition becomes, so your answer becomes uh, cosine theta. Cosine theta is x. So x is negative, and you can see this negative. And sine theta, this is for the second one, right? Second quadrant is y, and y is positive. So tan theta is sine theta over cosine theta, and you can see it is minus over plus is minus. In the third quadrant, let's take this off. Let's go directly down to the third quadrant. So if you check this, go this one. What is this basically means is the angle from here to here. See, a big angle. Maybe remember if I start from here, this is like a 90. If you go this way, it means 90. You go another here is 180. This is 180. And 90 also is pi by 2. And 180 is pi. Okay, so if you cross this 180 mark, if we go this side, see, so in both are minus and minus a. So that means your x and y. So here, in the third part is you say you have a lot of room to write at the bottom. So cosine of theta is x, and x is negative. Can you see this x is negative? And sine theta is y, and that also is negative. And tan is y over x, and that is minus over minus, minus minus is plus. So tan is positive. So I hope that takes care. Now let's do the last one. The last one is if this angle is this way. What that means is the angle is all around like this. It's crossing 270. This is 90, this is 180, and this is 270 because there are 1, 2, and 3 90s. So it's also 3 pi by 2 because one of the 90 degrees is pi by 2. And once you have this, this terminal is now x and y, which is plus and minus, right? Plus and minus. That means when you write cosine of theta, cosine is x and x is plus. And you can see sine theta is y and y is minus. So when you write tan theta, that it means it is y over x, which is minus over plus is minus. I hope that helps. So basically all you remember is that when I take this off is, this is how you're supposed to remember is in the first quadrant, because this is plus and plus, all sine and cosine and tan all are positive. So all positive. But if you go this side, this is minus and plus. So it is, so cosine here is, so this cosine is negative and sine is positive and tan is negative. So only sine is positive. Like that you will see here this side tan is positive. And if you go this side, it is cosine is positive. So you can remember this also. Nice to remember is which quadrant, which trigonometric ratio is positive. So we can say, okay, in the first quadrant, you can say add sugar to coffee. So what that means is all means all are positive, sine, cos, tan. Here, sine is positive. That means cosine and tan is negative. In this case, t means tan is positive and sine, cos is negative. And see, this coffee starts with C, so cosine is positive. Okay, so let's go to the next task. In this question, they're asking us, let's make it bigger. Suppose that the radians is in the fourth quadrant and of the unit circle, and the cosine of the angle is given. What are the values of sine theta? So a student by name Andre, he says he used Pythagorean identity and he checks that sine theta is this. using the values of sine cos, he does this work. I want you to stop the video for a while and see if you can understand this. Now you are supposed to explain how what is that he did. So whatever the Andre did, we need to write down. So what Andre did is, remember, he uses the Pythagorean identity. Now what that means is, watch this again one more time. If you forget, I like to show this. Not this. So this is the y-axis and the x-axis, and there is a circle like this. Okay, and you can draw. So basically, this one. Look at this, and okay, let me draw this. Okay, this one. So remember the earlier also I showed you that when you have a triangle, this is one, this is like your x, this is x from here to here, and this is y. So this is always your x and y, which is cosine and sine. So what he did is, Andre, what he did is he uses the formula x squared plus y squared is 1. 1 square, this is a Pythagorean identity. But what that means is x is cosine, right? So he uses cosine of the whatever the angle, and then he puts like this, then sine of the angle, and he squares and he put it 1. But then this is already given, you just plug in cosine right here. So this becomes 0.28 the whole square plus sine theta the whole square equals 1. And then he subtracts 0.28 both sides. Is it minus they give? Oh, this is in the fourth quadrant. So the way I have done it is wrong actually. Because this angle should have been, let me draw that. So this angle, this is in the fourth quadrant, something like this. Or I can use this one. That's way. So the angle is this is the angle here. So this one is given is 0.28. So the question is, what is this, right? Or so you can use even this basic. There is a triangle there. This is one, and they give you the x. This is given to you, which is 0.28. That's x. And all you do is just basically use this also. But I want you to get used to this kind of form. You get sine theta, the whole square is 1. Then, so this is square. Then you subtract this part. It means you're subtracting 0.28 both sides. And this crosses out. And what you're left with is sine theta square is 1 minus 0.28 the whole square. And then after that, what he does is, he says, okay, now we can write sine theta, the whole square is plus minus square root 1 minus 0.28 square. But remember, this is in the fourth quadrant. So if you see in the fourth quadrant here, this is plus and that is minus. That means cosine is positive and sine is negative. So your answer has to be minus and not plus. So I'll take off this one, and your answer is, so when you put a square root here, put a square root, this square root and 2 goes away, and you're left with sine theta is minus 1 minus. Using the calculator, you can figure this out, and you're done. That's all it is. So the question was asked. If you work that out, you get 0.96 on the calculator. This is minus 0.96. So once you get sine theta, then you have tan theta. So what is tan theta is sine theta over cosine theta, right? And then you know those values here is written down. So he did it right, sine theta over cosine theta, plug that in and use the calculator and you get the answer. And I hope that helps everyone. Let's do the next one. This question is about, they will give you something. See, where's the point? Now, sine theta is given in 0.5. So there's also given sine theta is minus. So what I'm going to do, I make some changes here. And I want you to write this in your paper. So where is this point? So sine theta is given, and imagine you are also given it is in the second quadrant. Let's write second quadrant. This is the so I want you to write this. This is one information, and also I want you to write they gave you second quadrant. So this is second quadrant. So what that means is when you draw like this way, it is like here second quadrant. So the angle is this is the starting, and then it goes like this, and then this is like a minus and plus. This is cosine, and that is the sine, right? So if it is the second quadrant, you're asking what is cosine of theta and what is tan of theta. So in the second quadrant, so all you do is you use the Pythagorean identity, and that is so you write down sine theta. Let me make it smaller. Sine theta this square plus cosine theta is 1, right? So all you do is plug this in. This is 0.5, the whole square plus cosine theta, and we don't know that, is 1. And this becomes 0.25 plus cosine theta is 1. Then you subtract this 0.25 both sides, 0.25. So this goes up, and I forgot to put a square here. So you get cosine theta. So this square is, if you take away 1, take away this, it becomes 0.75. And then you put this and you write down cosine, because the square root goes away with the so you get cosine theta becomes equal plus minus and square root of 0.75. And because you are in the second quadrant, because that's what we said, right? Second quadrant. So if it is the second quadrant, cosine is negative. So you write cosine is a negative, and use the calculator, whatever, see on your yellow calculator, pick it up and find this. That's the answer. Once you get this, this problem still not done. So now you do 10. So 10 is so let's see, sine over cosine. And if we do, what is 0.75? I'm trying to put on my calculator. So if I take square root of 0.75, we get 0.86. So this answer is minus 0.86. And now you have this one becomes 0.5 divided by minus 0.86. And if you divide this, you get 0.58 approximately, and you're done. So likewise, I showed you one, and you have to do the second one. Now take a note. Let me wipe this whole thing. So if I showed you one, I want you to do one by yourself. Imagine this one. They gave you this. Uh, you use the same trick idea, but for this you take third quadrant. So I want you to do this using this one with the third quadrant. And this one you can say fourth quadrant, not fourth quadrant. This one you can take second quadrant. Okay, the idea is the same. Imagine now I did this and you want to do this one, right? And this is again, or I could have taken this in the, let's say this is the third quadrant. So it means you are given a point that this is the angle and goes this way, and you have x, y, and cosine is given minus 0.8. So you're supposed to write this is your x and y, right? So it's better to find. So you're given this is the cosine of the angle. This is theta. So this is given, and you're supposed to find out what is sine of theta. And use the same idea of writing down sine of theta square plus cosine of theta square equals 1. Now you're given cosine is this, so this becomes minus 0.8. Okay, and if you do that, minus 0.8 if you square, you get 0.64. So sine theta 0.64 equals 1. Then subtract 0.64 and you get sine theta square is if you subtract you get 36 plus 0.36. And if you take the square root of this both sides, if you take a square root, it is plus and minus, but our goal is in the fourth quadrant, so in the third quadrant, we are in the third quadrant, right? Both are minus. So it has to be minus, and square root of 0.36 is 0.6. That's it. And tan is sine theta over cosine theta, and which is I got answer as both point. Sine is 0.6 and minus, so 0.6 and minus, both minus 0.86, and you do this, you get positive. You see 0.6 divided by 0.6 divided by 0.86, you get 0.69, and I can round it to 0.7. Right? So this is all I'm supposed to do, even though there are many of them. Let's see one more. And the next one is one which is a little hard here. So they gave you, let's see this problem sheet. Okay, let's check this. Okay, let's check this one. So sine is this, but imagine this was given in the fourth quadrant. Let's talk about fourth quadrant now. Okay, so if this is given, the idea is the same. Sine theta, okay, square plus cosine theta square is 1. Now sine is given here, so it is minus square root of 3 divided by 2, and you have to square this, plus cosine theta square is 1. And now this, if you square root 3 will be positive, you get 3 and 3/4. Then you subtract negative 3/4 both sides. So when you put a line, this goes away, and cosine theta will be 1 minus 3/4 is 1/4. And then you put a square root both sides. And what is the square root of? Square root of cosine theta will come plus minus half, because square root of 1/4 is square root of 1, square root of 4, which is 1/2. So, but then remember, we are in the fourth quadrant. So fourth quadrant, the angle is, see here, so the angle is plus and minus. So x is positive. So this is x and y. So cosine is positive and sine is, so this cosine has to be positive. So no more plus here. So it is plus here. We're done. So then also you're supposed to write down tan. What is tan? So tan theta is sine over cosine. So sine was, so what was the sine? Minus root 3 over 2, minus root 3 over 2. And this one you got half, and you can keep change flip here. So you can use keep change flip, that is minus root 3 divided by 2, and you flip this 2 over 1, and you can see 2 crosses out. And what are you left with? Minus root 3, and you're done. And this is how you're supposed to do the rest of them. So I'll leave that to you to complete. And then one more thing I wanted to show is they ask you also, this is a cool down problem. You can write this at the end. So yet again, another problem using the same idea, cosine is given in the second quadrant. So if it is the second quadrant, that means it is minus and plus. So cosine is negative and sine is positive. So all you do is the same thing I already showed you. You do it yourself. So this is square. And the only thing, instead of sine, they give cosine here. See, cosine theta. You use this Pythagorean identity, plug this in here, and you say, okay, sine theta square is plus, sorry, this is plus, this is plus minus 0.5 square, and you go on doing the work. Thank you. So this is takes care of problem lesson number 6. Okay, and I'm gonna do the next is lesson number 7 because both lesson 6 and are combined. So you'll be getting a packet that will have 6 and 7. All the best.